Okay, I'm going to cut myself off of the last one. We'll continue here with 5.62. So I wrote up the first two equations they give you, and then they ask you with these two equations here and here to calculate the heat of reaction for this equation. All right, 3 hydrogen gas plus O3 gas goes to 3H2O gas. Alright, so since delta H is a state function, it doesn't matter whether I just calculate that directly or if I can figure out how to get there using two other equations, like in this case this one and this one. If I can rearrange these two, here and here, to equal this one, then I'll also get the same answer, or should be close to it, as had I done this equation here just by itself to begin with, or looked it up. So you notice on the first equation here, I've got hydrogen and water, so H2 and H2O. Alright, well, I've got hydrogen here in the first one and H2O here in the second one, so I need that. Then notice here I've got an O3 and an O3 up here. The only thing is O3 down here is on the products, and up here at the top it's in the reactants. Alright, so first, since this is a 2 and this is a 3, I've got to multiply this equation by something, this first one. I've got to multiply that by something to get a 3. Well, 2 multiplied by 3 over 2 would give me a 3. And the same thing, what did I say, 2 over 3? 2 times 3 over 2 would give me 3. And 3 times 2 over 3, 3 over 2 times 2 over here would also give me 3. So I need to multiply this whole thing, including the delta H value, by 3 over 2. Okay, so if I multiply everything by the 3 over 2 out front here, times this original equation, which I messed up here, that's supposed to be a 2 originally, just like up here. Anyway, then notice that the 2's cancel, so here I get 3, here I get 3 halves, here I get 3 again, and then I multiply the 483 times 3 halves, I get 725.4, and I forgot to put negative there. Alright, so now I'm going to do the same idea with the second one. Notice that now I've got 3H2O here on this end and 3H2 over here, which is what I need up here and here. Okay, but now I've got to get the O3. Well, I've got an O3 here, but it's on the wrong side. So I'm going to have to reverse this, and I'm going to put 2O3 goes to 3O2, and when I do that, I've also got to change the sign for delta H. So it was positive 284, now it's going to be negative 284.6, and I'm almost there, except for look, in the equation they're asking me about, the O3 has a coefficient of 1, but down here I've got a coefficient of 2, so I'm going to need to divide everything by 2, including the delta H value. I can put that like this. Alright, so if I do that, then I'm going to get O3 goes to 3 halves O2, delta H equals negative 142, let me fix that, 142.3 kilojoules. Okay, so now look, I've got an equation here, kind of a mess, but here, and then another one up here that I can combine, and I can add these up, and everything's going to cancel to give me the equation that I'm looking for up here. Okay, so now I'm going to switch pages and get that started. Okay, now I've written down the equation we're looking for up here, And then the two equations that I kind of redid. The first one, remember, we multiplied by 3/2, and then the second one, we turned it around and divided by 2. But look what happens now when I add these up. Notice that I have 3/2 oxygen on the left side and 3/2 on the right side, so those are going to cancel. And then that leaves me on the left side, on the reactants, I have 3H2 gas plus O3 gas goes to, the only thing left over here is 3H2O gas. Now notice that that's the same thing I have up here, which is the equation in question. Well, I can do the same thing here and add these up. Alright, so I have 725.4 plus 142.3. Add those up and I get delta H equals negative 867.7 kilojoules. Okay, so that is the question we were looking for up here. That's the delta H value of this equation, figured out by combining two other reactions and adding up their delta H's. So when you come up with the delta H value of a reaction, not going directly through like this, but by using two or more other reactions and combining them, that's what we call Hess's Law. And that simply states that the way in which you get the delta H value doesn't matter. It's going to be the same whether you go through other reactions and add them up like this, or if you do the same reaction by itself, which is the same thing we did in the lab, which we'll figure out if that's going to give us the correct answer or not. Reactions 1 and 2 should add together to give reaction 3, which you did separately, and we can compare those values. Alright, so that's the answer to 8.62.